All right, very good. Well, thanks for the invitation. Nice to be here. Yes. Let's go. So the Columbus number means laboratory data. You may be interested in that or not, but that's what I've been doing for 50 years. And then there's a table on the internet that unfortunately isn't always understood. So we're gonna hopefully clear that up. There's the top 8 radios on my website out of 158. How many have been to that website at least once? All right. So let's back up 51 years ago. Now, the specs that were available back then were sensitivity, selectivity, particularly once we got a Collins mechanical filter, and then a term called cross modulation that was an AM thing. I've never heard the term in 20, 30 years. In 1975, this all changed because QST and Ham Radio Magazine, and hopefully we all wish the Ham Radio Magazine was still around. But anyway, in 75, they published different specifications. So here we are, noise floor. That was a new term. And it was in a CW bandwidth. And also two-tone dynamic range, which was really a much better measurement than this cross modulation. But the testing was only done at 20 kilohertz, which meant you had 2 signals, 20 kilohertz apart, and you're trying to find the distortion product that was either up the band 20 kilohertz or down the band 20 kilohertz. And that was already obsolete with the R4C that I had. And then along came the TR7 just a few years later. It was the beginning of the upconversion radios. That's all we had for like 20 or 25 years. So what was the problem? The topology of the radios had changed. We had a wide first IF, usually 15 kilohertz because it was an FM filter, above 10 meters or above 6 meters. So we had that wide filter, but you get a whole lot of signals, particularly CW already, and 15 kilohertz. Lots of gain, and that was the deal. We might have 30, 40 dB of gain, and then finally a crystal filter or mechanical filter and some other IF. So the trouble was, particularly for CW contests, de-expeditions, de-exing, the radio could overload, and you'd never know that from the 20 kilohertz test. So 1 year later, in 1976, I started testing at 2 kilohertz, and it took the league forever to get there, but they're there now. So this was the situation. You took the average upconversion radio with that 15 kilohertz filter, and the dynamic range was 80 or 90 dB. Like, what's the problem? But if you then had the signals going through the roofing filter, the dynamic range was between 65 and 75. So just take the average of 70. The difference between 70 and 90 is huge in a big contest or the expedition or whatever. So where are we today? Well, both QST and I published 20 kilohertz and 2 kilohertz data, and it may also be an RSGB. On my website that you've been to, there's 14 columns with data on 158 radios. Now, you can only sort a table on one column. So I sorted on the close end 2 kilohertz dynamic range. All that other data is there, but they're not sorted. You can only sort on one column. So most hams only look at that one column that says the 2 kilohertz dynamic range. But it's not an overall ranking. People think, well, the top radio is the best radio in every aspect, and that's not the case. It could be theoretically, but not usually. So all the other columns, you got to look at something specific. So you want to know what a Yaesu and an ICOM, you want to know what the noise floor is, you just got to look up 2 radios and there's your numbers. So I was listening to a podcast about 2 months ago, and the guy was talking about the new FTX1. Does anybody have one? It's okay, at least one. And it can be a QRP version or a 100-watt version. And he was comparing it to the ICOM 705, NE 705 owners. I enjoyed running it in a couple of contests with a nice little radio. Particularly if you're using the ICOM, they all work the same. So because the dynamic range of the Yaesu was 3 dB higher than the diamond range of this icon. He said, well, the Yaesu is more sensitive. But it had nothing to do with it. This sorting of the radio's dynamic range has no correlation with whatever its sensitivity is. So if you look down below, you'll see that the icon at 0.67 microvolts was more sensitive than the FTX1. Now, that doesn't mean you can't hear. Of course, you got preamps and all that, but that was something sort of a wake-up call to me that I said, I got to deal with this because people are making assumptions that have nothing to do with reality. So just like I just gave that example, that you can compare the sensitivity, you need to do that if you're interested in that parameter. So what else do you not want to do? Today, don't choose a radio with one number. Now, you could say maybe back there in 1976 or 77 or up to 1980, there were very few radios that had really good numbers. So there might be a difference like when the Orion 1 came out. It was a 90 plus dB radio. And most radios were 70. So you could almost say, well, I'll pick out a radio with one number. But today, we have so many radios that have tremendous performance, 90 dB or more. I would say there's probably no one in this room where we need more than 90. The other thing is, don't get hung up on noise floor or sensitivity, particularly if you're in an urban environment. Probably the band noise and the RFI is the problem. So what I want you to pay attention to, if you say, I want to get a new radio. Well, you need to really sit down in front of it. Hopefully you can have a friend that maybe already has a member of your club here. The difference between all these radios now is, how do I interface with the radio? Does it have knobs or touchscreen? And how many buttons does it have? What's the display size? Can you feed an external display? Some people like that. I don't do that, but some people have great big monitors. Does it run with a computer, like a Flex or an Apache? Or is it standalone? Take it out of the box, plug it in. The ergonomics are all over the map. What you find easy to use, I might find confusing. Also, the menus. The menus will set up your default. Hopefully, you don't have to go into a menu when you're trying to work North Korea. And say, well, where's my menu? And all of a sudden I missed North Korea for the one chance. So become friends with your club members. Of course, there's Boulder Amateur Radio Club, there's the Denver Club, so make use of what's around. And we've got HRO, we're lucky. There's what are there, like 10 HROs or whatever it is. Make use of what's the stores have. So the one thing today is the basic performance of all our major OEMs, all 6, including Apache. They're probably the smallest. You know, Yaesu, ICAM, Kenwood, et cetera, Flex and Telegraph. You can contest DX with any of these. I don't think you could ever say I've lost a contact because I didn't have a good enough radio with what's available today in the last 10 years, let's say. So we've got, back then, 20, 30 years ago, we want 100 dB radio. No such a thing existed. Now, you'll see in a moment that 100 dB radios are common. It's hard to believe. So then you've got other choices. What brand are you familiar with? And maybe you want to stay with whatever brand you've had. What's it cost? Your budget certainly is not insignificant. Pricing's all over the map. And how big is it? Are you going to take a 35-pound radio to a soda site? I don't think so. So, fourth quarter of 2022, I operated for 3 months with a $1,000 radio and a $1,500 radio. Those happened to be with the Yaesus, and I'll show a picture of that. But the thing was, the user interface was so different than what I was used to, which happened to be an icon. So it's just all over the map, and there's no right and wrong, but they're all different. So this was, I have 3 operating positions, not because I'm a multi-contester, but I need to evaluate radios. So in this case, I had to tear down my standard radio, and I put an FTDX10 in there under the monitor. And there's on the right my 6 rotor controllers for the 6 towers that are full of monoband beams. And then the next radio with operating position number 2 was an FT710 under the monitor on the left. So that's what I did for 3 months. Brag chewing, contest, DX, whatever. That was really An advantage that I didn't have 30, 40 years ago, because I'm now out in the country with a lot of antennas and a lot of quiet operating location. And so, since you have seen my website, now this is the top 26 radios, not the first 26 on the listing because there's duplicates. There's a K3, there's a K3S, there's even a K3S compared to a Flex. Then there's all the direct sampling radios, you know, like a K4 or something. They're different. Unlike the legacy radios, the superheads, if you tested 2 or 3 of them, they'd almost be identical. But the direct sampling, because every ADC chip, analog to digital converter chip, is different by a little bit. You know, 3, 4, 5 dB. I think the most I've seen was 9, but it's typically not that much. But there are 2 in there. It'll say second sample, and the second sample might be higher than the first, or the second sample may be lower than the first. It just gives you an idea of data scatter. So look right there in the middle, either 99 or 100 dB radios. You can't go wrong. And even the bottom one on the list there, 87, this is not a problem. And look at the price difference all over the map. So of these 26 transceivers, I've operated 20 of them in a major contest, mostly CW, mostly 160 and 10 meters to get the range of signals. And once I on CQ Worldwide CW that's coming up, I'll be using the X1, so I can say I'll work 21 of these radios out of 26. So how are you going to select a new radio? Well, I'd say pick one of those 26. You can't go wrong. You can pick anything you want, but that's a lot of choices. All the brands are there. If you have been running Yaesu forever and want to stay with it, pick one that fits your budget. The price range today is astounding, $1,000, occasionally a little bit later when there's sales, up to $9,600 for the newest Flex with the 500-watt amplifier. So the prices are all over the map. But what are you going to take on a de-expedition? Probably not a 50-pound radio. So it depends what you're going to do. So now we're going to look at some of the lab numbers and what they do mean to you and what you should pay attention to. So from that chart that you're used to, noise floor is on there, and it's almost insignificant today. If you're in the city, local noise is target limit. But you may go out on a soda side or a POTA side or just want to get away from the noise of your home QTH. So if you are at a soda site or a POTA site, then you do definitely want, with a limited antenna, maybe that sensitivity value is important. But I'd say, before you do go buy a new radio, can you improve your antenna? That's the most important thing. You got location, but you're probably not going to move. You've got your antenna. And then if you're in a DX pilot, your skill at operating a pilot, and then I'd say your radio, because we've got so many radios today, you probably are not limited by your radio. When the ICOM 7300 came out, and that's about 8 years ago, maybe approaching 9, and sold 100,000 of them. I never felt I missed a contact, even though it's a relatively inexpensive radio. AGC threshold. I don't think most people think about this, but band noise is usually above the threshold. So that means the estimators may be reading upscale. And that's not the ideal way if you're going to be in a contest or a DX, trying to work a de-expedition. If the AGC is running on band noise, then every time you're tuning, let's say you're search and pounce. In other words, it's a contest and I'm searching and pouncing, or if it's a de-expedition, I'm listening to the DX. But you don't, and I also maybe want to know, well, who's he working, and I want to sort of squeeze in there. If the AGC is running on band noise, then every time you listen between stations, it's going to be as loud as the signal. And that's tiring, particularly if you're on the air for hours. CQ Worldwide was a couple of weekends ago, sideband. I was on the air for 18 hours. And if you're listening all those hours, you really don't want to hear the band noise that much. Of course, on 10 meters, it wasn't an issue. Pretty quiet where I am. But if you're on 75 or 40 meters, of course, band noise is really significant. So what can you do? You can back off the RF gain a little bit so that the band noise drops audibly, but not tremendous amount, like 6 dB. Or you can use your attenuator, or if you have a flex or an Apache, you can adjust the threshold separately. So make use of your threshold if it's there directly with a slider, or use the attenuation, either RF gain or the attenuator. Blocking. You probably don't have this problem unless you've got a, let's say, a station within line of sight. Now, a superhead will eventually block. The signal could be out of band if you were on 40-meter CW and there's a broadcast. Let's say you're in Europe, you know, 40-meter CW. There's a megawatt broadcast station on 7.25 or something. That could be overloading your radio. So most of the time, though, with modern radios, you probably won't block it. But if you want a number, 125 dB is a good number, and that's about the limit on most of the direct sampling. But like a K3S, it's 150, but you probably don't need that. So sensitivity is a 10 dB signal plus noise ratio. That's different from the noise floor, which I didn't mention. That's a 3 dB signal plus noise to noise ratio. You wonder what was sensitivity a long time ago. So I had a Collins or I had a Drake or whatever. What was it? Typical radio was 0.15 microvolts. And now with modern radios, usually you get 0.15 microvolts with the preamp 1 on. Not with no preamp, it's probably more like half a microvolt or something like that. So this really hasn't changed in 50 years. 0.15 microvolts is been a valid number for all the time I've been a ham, that's for sure. This is probably the least known and least concerned most of us most of the time, but this is called the local oscillator noise. And the measurement now since 2012 called reciprocal mixing dynamic range. So if we go back to our Collins and our Drake, for instance, this was a non-issue. We either had a PTO, permeability to an oscillator, or a VFO, and band crystals. So we didn't have anything that made noise of any significance. I mean, everything has noise, but it was not in the radar. Then along came synthesized radios. Well, that was great. We had digital readout, no drift, quite likely general coverage, but synthesizers were terrible. So we're lucky now in the last 5 or 10 years that this is a non-issue. Now, if you look at my website, we don't have an RMDR column because that definition was only defined by the ARRL in 2012. But my data goes back 50 years. So there's a column that says local oscillator noise in dBc per hertz, kind of an esoteric term. But if you want to know what the RMDR is, you just subtract 27 dB and change the sign. So instead of being like minus 127, then just take 27 dB off and you get 100. Front-end selectivity. Most rigs have either a half octave LC filter or a ham band only. Some have a tracking pre-selector, like the FTDX 101D, the MP, the ICOM 7610, and the 7760. So that's an LC filter that tracks either continually or stepwise. So I just said, let's measure the bandwidth on 40 meters. Well, with the Yaesu, it's about 250 kilohertz. With the ICOM, it's 500 kilohertz and minus 10. The strange thing is, I know if you happen to be a 101 owner, that you can off tune the tracking pre-selector. And I get people say, I can get rid of QRM 5 kilohertz away by off tuning the tracking pre-selector. It's 250 kilohertz wide. So how could you knock down QRM 5 kilohertz away? So what I think is happening is once you decide to tune it enough, it's increasing the insertion loss. So it's like just turning on an attenuator. But people swear up and down that I can get rid of QRM with an LC filter is 250 or 500 kilohertz wide, that's crazy. Now, you may need some other LC filters for field day if you've got multi-stations on the air at the same time. Particularly on the same band, you better pick a good radio in that case, because now, the filters for 40 meters, you've got CW, FT8 and sideband all on at the same time. Those filters aren't going to fix that problem. So finally, we're back to dynamic range. There's more than 20 transceivers with a close-in 2 kilohertz dynamic range of over 90 dB. So most hams just don't have to worry about overload. Roofing filters, though, are important in certain situations. So a radio that has a superhet front end and then it's digital. If it's got a roofing filter, let's say a 500 hertz or whatever, even if it's a sideband roofing filter. If you've got stations like on field day, you got FT8, sideband, and CW. That roofing filter is going to make a 20 dB difference as before the radio blocks. So you need to carefully pick your radios for, if you've got a big field day operation, then I would say consider one with a roofing filter, which is not just a direct sampling radio. It's got a superhet front end and then digital. So when are you going to need that? Line of sight. If a signal is 60/9, 70/9, then roofing filter helps. Field day in particular. And if you got a multi contest station, the run station's banging away, but the vault station's tuning around, and he may want to get in within 5 kilohertz of the run station. So that's the case where the roofing filter really makes the difference. This is a lot of numbers. I'm going to synopsize this. This is saying when will a 100 dB radio or 99 dB radio potentially see a third order intermod limitation, which is the definition of dynamic range. Well, on 10 meters, in a quiet location like I was for CQ Worldwide, the noise floor of the radio and the band noise on 10 meters with the band wide open are about the same. Most of the time, band noise is way above receiver noise. So it was about the same. So then how strong will the two signals, the right frequencies, have to be to cause third order intermodulation equal to the noise floor / band noise? About S9 plus 45 dB. Probably not going to happen. Now, I was on the air for 18 hours for CQ Worldwide sideband. I never saw a station 45/9. The conditions were phenomenal. Now, I was just a little pistol, but I worked 118 countries and 34 zones. So and I was on the air for the 18 hours. If I had been signals at 50/60/9, I would have seen it, and I didn't see that. So you really don't have to worry about with these radios today. They're phenomenal. Your 100 dB radio is like magic. Now, if you were in Europe, WRTC was there. I guess we're going to have our WRTC next year. One of the operators was running a 7610, and he was complaining I had to run 9 dB attenuation over 40 meters or the radio was an overload. Well, on 40 meters at night, band noise, assuming it's not local noise, is about a minus 100 dBm. The receiver is going to be like minus 130 on noise floor. You don't need a 30 dB difference between noise floor and the band noise. So put in attenuation. You lose nothing. You're not going to miss the weak signal because the band noise is the limit. So in that case, I probably would have just started out with 15 dB or 12 dB, and not 9. But I think that was the case where the user didn't realize he was not losing anything by running his 9 or 12 dB attenuation. So I would say the biggest mistake most people make is the radios are really sensitive enough for 10 meters, and now 6 meters, everything covers 6 meters. But then on the lower bands, they're too sensitive. You know, how can a radio be too sensitive? Well, it's got that noise floor that's way below band noise. Now, you do want your sensitivity or your band noise to be 10 dB below band noise. That way you're not losing anything at all. So consider using keep your preamp off in the low bands, use your attenuator when appropriate. And like on 75 meters, I typically are running 12 dB attenuation, even at night on 40 meters. So we don't need the sensitivity that you need on 10 and 6, and even 12 and 15 on 40, 80, 160. So how do these upconversion radios replace the downconverting, or replace with downconverting radios? So the Orion 1 came out, and that was the first time that a regular OEM changed back to the low IF, low meaning like 9 megahertz, 8 megahertz, or whatever. Everybody had gone to upconversion because we didn't have to have a preselector, they had a tune, or a tracking preselector. You got simplified the design, but he had a trade-off. So when the Orion 1 came out, and later the Orion 2, and then of course the K3, that changed everything. Because almost all the radios that were upconversion, remember I said they were about 70 dB dynamic range. That was adequate for sideband, but not for CW. And Meridian, I assume, was the same thing. So that was the big change. Suddenly, the 70 dB radios couldn't compete with the 100 dB radios. The A3S 105, the very expensive 7851 that is an upconversion radio, but that roofing filter is a killer. It's wide approximately. It's like a $300 filter. So that also had 105 dB dynamic range. One thing to clarify, the 7760 that replaced, in effect, the 7851 does not have a roofing filter. The 7851 has roofing filters, the 7760 does not. It's a standard direct sampling radio. By pure direct sampling, no roofing filter ever. So the dynamic range of today's direct sampling radios is between 97 and 107 with the built-in linearization turned on. Sometimes you don't even turn it off. Now the ICOM 705 doesn't have that linearization called dither, but it's got an 88 dB dynamic range. So with the upconversion radios, you ran a test at 20 kilohertz, you got a big number, and at close in, you got a smaller number. When you're testing a direct sampling radio, it really doesn't matter what offset you're doing, 20 kilohertz, 10, 5, 2. Because again, there's no roofing filter to affect that measurement. So what rig should you own? I'm often asked, well, why don't I own the top radio or two on my website? And I actually have owned the FTDX 10, which I still have, the FTDX 710, which I ran there for 3 months. I did sell that. But for me, I want to pick a radio that works with the human interface for me. The way I think, or the way the band scope works, the way the waterfall works, all that subjective stuff that doesn't have anything to do with lab numbers. Because all these radios are so good, you really need to pick one that works for you. So this is subjective though, and there's no way to put that in a table. So I happen to like the ICOM interface, but other people say, well, I like another brand. Fine. So we just talked about receiver numbers. Well, what about transmit? Right now, what do you do to clean up the bands? The ARRL for now almost 3 years has been working on the Clean Signal Initiative to try to get OEMs to reduce key clicks, reduce splatter on sideband, and to reduce transmit noise that bothers everybody else that's nearby. So I'm going to talk about the improvement in sideband splatter available by something called pre-distortion, or maybe it has a specific term by brand. Like you've got pure signal from Flex, smart signal, pure signal from Apache, smart signal from Flex, and then ICOM calls it DPD, digital predistortion, that's a generic term. So of the 6 major OEMs, 3 have some type of predistortion, linearization, splatter reduction. Now, the Flex software is still in beta. The ICOM DPD has been out now since Thanksgiving 2 years ago. So I've enjoyed to get to use that just for the firmware update. And Apache's had it for 9 or 10 years. So here was a screenshot taken by W0IVJ in Boulder. And I was on the air on 75 meters with some other, we'll call them local signals, NVIS, within a radius of 100 miles or so. Now the ways to clean up the signal, we had Class A with a couple, three Yaesu rigs, the Mark V, the 1000D, and the Mark V field. But that's gone. The 101D and the 101MP no longer has Class A, so that's out the window. ICOM has this digital predistortion. K4, nothing yet. They've talked about it since the introduction of the K4, but we're not there. So let's look at this screen capture in Boulder. The signal on top of the waterfall is a 9-year-old Apache 200D running pure signal with the adaptive predistortion and the amplifier in the correction loop. So look how straight up and down, that's just virtually a rectangle. Just the slightest hint of a little splatter on the right-hand edge. But look, you can see some sort of an interfering signal there wandering around. It's probably a switching power supply or who knows what. But it's real obvious because the signal is so clean. Down below, someone running a TS890S. Oops, that was me. Running an Alpha 89. Now, it's a good rig, it's a good amp, but no predistortion. So look how much wider the signal without predistortion is, about 3 times the width of its standard signal. Now, you have to be really strong to see this. If you're S9, you won't see all this. But the signals are about 30 over 9 on 75. Now, I have to admit that my signal there, the main signal there in purple, is a little bit stronger than the Apache, but still, you're about 3 times as wide at minus 50, let's say, on sideband without predistortion as with it. Okay, here's the next one where I got to shine. The signal on top was a 7610 driving an ACOM 1000, not in the correction loop. See, the tube amps are so much cleaner than your solid state amps that you can get away with not having the ability to put the amp in the correction loop. So again, you can see just a couple little dots off to the right of my main signal. And then down below, that's a Flex 6600M driving a Power Genius XL at W5AP. Again, like that a previous slide, the signal's splatter bandwidth is about 3 times as wide as the main signal. If you look up at the top, that's the band scope. When this picture was snapped, the Flex just started to talk again, you can see. So you can see the splatter is not only obvious on the waterfall, but there on the band scope. So it's the distortion products are only locked in about 35 dB in comparison to 55 dB with predistortion. Now, we can get the other 3 OEMs to have that, we'd have a lot cleaner bands. So the Apache Annan has what Warren Pratt calls pure signal. He now lives in Loveland. He's written all the DSP code for Apache. Now, all the rigs work barefoot with predistortion, but they don't all support a third-party amp. Again, a tube amp probably doesn't need it, but at least with the pure signal, you can put an external sampler, like on an L4B, something really old, and make it in the correction loop. Now, pure signal calculates the correction factor on the fly, so it's continually doing this. You don't need to calibrate it like you do with the ICOM, and it doesn't change calibration as like the Flex does. If you move more than 10 kilohertz with the Flex, it's in beta, but it still works. it recalculates, so they just work differently, but probably doesn't matter. Comments on the 7610 and the new 7760. They both support ICOM's digital pre-distortion barefoot. But ICOM only supports the PW2, not even the PW1, let alone an alpha or whatever. The 7760 is a 200-watt rig. The 7610 is a 100-watt rig. If you, whichever rig you pick driving the PW2 comes out the same. The 7760 is about 8 dB cleaner than 7610. But once you drive the PW2, it's a wash. So if you don't need a 200-watt rig to drive an amp, which you probably don't, you'll work just fine with the PW2 on. The other 200-watt rigs are the 101 MP, TS990S, and the Apache 8000. And flex radios, they're calling it smart signal instead of pure signal. It's still in beta. I think Steve Hicks said that by first of the year, they'll hopefully be supporting an external amp. You can calibrate with your voice and just let it calibrate automatically. You can use the built-in two-tone test. As I mentioned, if you change frequency more than 10 kilohertz, it'll recalibrate. But the smart signal is only going to work on the 8000 series. So if you are a 6000 owner, no matter what, and then this new Aurora, which is the download. So important things to consider. We have rigs all over the price range from $1,000 to approaching $10,000. Try to operate something the friend has if you're going to buy a new rig, because you may find it's a great match for you or it may not be. Few amps really need more than 90 dB radios. I mean, we've got 110 to 90, but it's rarely you're going to be affected by that. Now, back in the days of 70 and 60, a different story. But so we need Elecraft, Kenwood, and Yaesu to offer pre-distortion. Luckily, the tube amps will work quite well with a rig that doesn't support an external amp. So like in my case, I'm running a 7610. I've got an alpha amps, I've got ACOM, they work great, as you saw in the picture. But don't pick a radio just on one number. I mentioned that on a CSI meeting talking to Steve Hicks. And I said, I've kind of created a monster. Back 50 years ago, the difference between 70 and 90 was enormous. Now the difference from 90 to 110 is not, because we're got more performance than we need. So if you have any questions later, I've got the PDF, as your club has a copy of the PDF of this. It's just frustrating that people make assumptions that the ranking is every aspect of a radio is not. The ranking is by close-in dynamic range. Everything else you're going to have to compare. The bottom line is, do you enjoy running your radio? It's supposed to be fun. This should be a hobby that you get off the air and like, that was fun. If you're struggling with your radio, well, consider something else. But today we're so lucky on what's available. You can hardly go wrong from a performance standpoint. There's my email, rob@nc0b.com. So if anybody wants a copy of the PDF or they just want to ask a question, I answer my emails. Do we have any questions here in the last 5 minutes? Yes.
Does any of this apply to the VHF FM radios? I mean, you don't rank them. You've never ranked them.
Well, actually,
I mean, is there equivalence to selecting one of those?
See, when we had a VHF UHF conference here several years ago, so I did present data on the VHF UHF radios. They consistently get worse. Dynamic range is worse. Transmit intermod is worse. 2 meters is at least 10 dB worse than 10 meters. 70 centimeters is probably 15 dB worse or worse. So unfortunately, there's not been, all this technology has hardly trickled down to the VHF UHF. I'm talking about sideband CW FT8.
Right.
The ICOM 9700 is a nice little radio. It was an upgrade for me from a 275H, but the numbers were not dramatically better, but the features were great. But we're really behind the times as far as the higher frequencies. Get back there.
Yes, which metrics are most important for different modes? For example, some of them obviously are gonna be better for CW, some for SSB phones, some for digital modes. I'm especially interested in which columns in your table I should be looking at for digital modes.
That's different. Digital modes. I'm gonna repeat the question.
Okay.
What?
Which columns
No, I'll
are you
repeat the
looking
question.
at for different modes?
Right, different modes, what's important? Well, digital modes, that's all signals are in band, so the dynamic range measurements are out of band signals. So the digital ones that are in band, not much is published. As far as in band distortion, I don't think QSD publishes that at all. They do publish harmonic distortion, but that's not much. So for CW, close in dynamic range. For sideband, you kind of can ignore it because splatter is the problem. Now, if we all ended up with signals like this straight up and down, then we'd be more concerned. So, and so CW is the most significant as far as the potential overload, but today's radios hardly matters at all. One more back here.
You mentioned 6 meters, and on 6 meters receive. A lot of people are running this external SDR rather than the radio receiver in the radio itself,
Right.
like AirSpy R2. Can you comment on, is that a real, is that really worthwhile?
I can't really comment on like an AirSpy and these little $100 and $200 dongles. I think they're really good for an external band adapter if your radio doesn't have one, but I can't really make a definitive statement. The league tests a lot of inexpensive dongle things, we'll call them. They kind of have to struggle at it because usually there's something else than the standard numbers they publish that are a limit. Like for instance, I tested what is it, Kilomax something or other. Spurs were more important than dynamic range. So I don't really know.
Okay.
All right, very good. No more questions. We'll turn it back to your